All right. Thanks everyone for attending. My name is Cody Hosterman. I'm the technical director at Pure Storage for our VMware integrations and solutions engineering team. So today I'm going to be talking about some of the major initiatives we've been working with VMware on, and just strategically important, regardless, to VMware ecosystems and VMware infrastructure. So before I get into those topics, I just want to introduce a couple concepts around Pure and VMware before we go into the more details around some of these initiatives from VMware into technologies like NVMe Fabrics and VMware Cloud Foundation. And really a key part of the VMware experience for our customers is the wide variety of integrations and solutions around wherever you want to run your VMware environment, wherever you want to run your workloads. And there's a billion different pieces and places where we integrate across that stack. But really the key thing around the value of this from Pure is the simplicity. This is a major part of everything that we do. Our integrations, our solutions aren't hiding complexity. They're demonstrating the simplicity of the underlying fundamental product. And there's a lot of things that we mean when we talk about simplicity. A lot of it is just the array itself, right? Creating volumes is super simple. We don't ask you to configure RAID or turn on encryption or turn on deduplication or how should I tweak this or change this. The array does that for us, for you rather. Customers pay us for our storage so our engineers can make those decisions and figure that type of stuff out. And simplicity is really what demonstrates the rest of the integrations and technology I'm going to go deeper into in the rest of this presentation, because simplicity of the underlying platform means a couple things. It's easier to integrate. It's easier to automate. The less you need to change around configuration, the better. I see best practices or best practice configuration settings or tweaks, more specifically, as essentially solutions bugs. Because anytime you need to make a change or a tweak to make it work better with your platform, the more access you need to give to the end users to be able to change the infrastructure, the less uniformity you have, the harder it is to automate, and the more access you have to give, the less secure it ends up being, and the harder it is to support. And that's a really key part of these solutions moving forward. So simplicity is not just about the product, right? It's an important part, and without a simple underlying product, and it's not going to be simple no matter what you do, but it's also around the simplicity of how it fits into that ecosystem. And so the things I'm going to go through today, we follow these guidelines when it comes to how can we introduce a solution? How can we introduce our product into some ecosystem like VMware to make it better and easy to use? And so we go through a thought process of how does this work with VMware product X or VMware ecosystem Y? Well, if it doesn't, is there something we can do from our side to make our product better so it just works right out of the box? Can we work with VMware or this partner to improve their product, to make it better, to make it more intelligent, to make it understand some defaults? So when these two things get plugged together, it works out of the box. If those aren't possible, or it's not the only part of the story, do we need to build some kind of integration or plugin to hook the two things together? And worst case scenario, or rather, it always ends in this and to some extent, but worst case scenario, the only thing we can do is, all right, let's just tell people how to do it. And we really try to avoid number 4, unless it's saying we've done one of these 3 things before it. So with all that said, let's get into the actual technology I want to talk about today. And there's 3 main things on the agenda that's been a significant focus, not only here at Pure Storage, but also, of course, with VMware and the industry in general, around on-premises and public cloud infrastructure, but specifically around VMware. NVMe, the adoption of that and driving that within the vSphere platform. VMware Cloud Foundation for more automated infrastructures. And of course, the talk of the town for today and for many years, and probably for many years to come, is, of course, containers and Kubernetes and where that's going and what's happening from a VMware perspective moving forward. So let's start off with NVMe over Fabrics. What does this actually mean? Why does this matter? Why did we even start working on it? Why was it introduced in the first place? And to really understand this, I think to frame this in the right way, it's important to understand a little bit of history. So many years ago, in a galaxy far, far away, in the ESX environment, the file system, VMware's file system, VMFS, was the bottleneck. it could only be so large. It could only have so much capacity. You can have only so many VMs on it at once. And there were a lot of reasons for this, other than it just being, 20 years ago. But a big part of this was how it did the locking. Scalable multi-host file systems is not an easy thing to do. And traditionally what was done on VMFS, in fact, was leveraging SCSI reservation. So when you booted up a VM, when you added a virtual disk, when you resized it, when you shut it down, when you snapshotted it, the host running that virtual machine took a SCSI reservation of that entire data store, locking all I/O from all other hosts until that lock was removed. And that was okay, but not at scale. When you started having many hosts, hundreds, thousands of VMs on a data store, that locking mechanism became untenable. And so performance at scale was not possible, even if the underlying platform could offer more performance than that data store was consuming. And so what VMware did a couple of years, or 6, 7 years ago, was open this up, offload it down to the underlying array. Instead of locking the entire data store, it would lock little pieces of it. And this is what's called hardware-assisted locking. So by locking small sections, small blocks of the data store when they need it, they could have concurrent locking. So many operations to many different virtual machines at the exact same time. No longer locking out I/O from other hosts because you need to add a virtual disk to one VM that's unrelated to hundreds of other virtual machines. And so what this did is it expanded the file system, the limits of the file system, to much, much larger sizes, from originally 2 terabytes up to 64 terabytes, really opening up the scale. You never really get rid of a bottleneck, though. You hopefully make it smaller and just move it somewhere else. And that's pretty much what happened here is, okay, VMware opened up their file system. They can allow arrays to do their thing. They can open up locking to much, much higher scale. But what happened here is that the underlying storage became the bottleneck. The underlying storage could only offer so much performance for that given LUN sitting underneath that file system. And there were many reasons behind this, but a big part of it was spinning disk. Spinning disks that got larger, but they didn't get faster. So you had to push them across more and more and more disks to be able to get that performance. And that wasted capacity because maybe you only needed performance, or maybe you needed that capacity, but you didn't need the performance. And so these things didn't scale in a linear fashion. And so the data store couldn't really use that new scale. And furthermore, things like VDI weren't really tenable either on a single data store, or even a couple. Because VDI, virtual desktops, you would boot up hundreds or thousands of them in the morning. So they need a lot of performance for 25 minutes and then very little for the rest of the day. And then in the evening, when it was recomposed, it would need it again. And so in order to deal with that, you had to oversize the performance of that environment for a small portion of the day. And then those resources were restricted and preserved all day long, and no one else could use them because that data store was using that physical LUN environment underneath it. And even if you did have some automated tiering mechanism, it could rarely keep up with these changes on a day-to-day basis. By the time it was moved, it was ready to move it back. And so the underlying storage became the bottleneck. And this is a key part about the flash array. The flash array itself, the Pure Storage block offering, is that volumes on our array, they are not tied to physical resources, and they're certainly not tied to spinning disk. It's all flash. We call it the flash array for a reason. A single volume can offer up all the performance of the flash array. So you provision 1 volume, 10 volumes, 50 volumes, they can use what they need to use at that time. If they're not using it, someone else can. You can restrict it with throughput limits, IOPS limits, etc. But sizing of flash array volumes, count of flash array volumes has nothing to do with performance. Large data stores, many, small, whatever. And that really helps with the simplicity of provisioning your storage environments in VMware or really elsewhere. When you're thinking about data stores or volumes, you're thinking about features. You're thinking about the business requirements of what's sitting on top of it, not the performance requirements of that application. Now, that's all wonderful and great, but VMware, but the flash array itself was built for flash, right? I mean, makes sense. We constructed and built the underlying software to leverage the efficiency, the performance, and the use around flash. But the front end layer, the addressing layer of that storage, even internally and externally, was not something that was built for flash. It was SCSI. SCSI was built for spinning disk many decades ago, and SCSI is inherently serialized. You could not push a lot of performance through that specification. And so what happened here with flash was something very similar that happened to disk, is that you got more capacity, but they didn't get faster because they were constricted to a certain layer. And in this case, the flash was constricted by the SCSI protocol, not only internally, but also externally to access the array itself. And so SCSI became this bottleneck. And so what is the answer for that? Well, the problem was looked at as like, well, how do we open up the concurrency of flash? Because the underlying NAND in these SSDs and so forth can offer a lot more performance. They're built for concurrency. It's kind of putting SCSI in front of a bunch of flash is kind of like having a 100,000 person stadium and having one entrance or 10 entrances or 30 entrances maybe. It takes a long time to fill that up. And so along came, of course, NVMe. The flash array is built for flash. SCSI is built for spinning disk. NVMe is, well, built for flash. It's built to take up that concurrency and offer that up. So instead of having 30 entrances or 10 entrances to that stadium, you now have a single entrance for every seat. So you can fill it. I mean, yes, it doesn't really make sense in a stadium, but you get the concept. Is it allows you to really leverage the performance of that. And so performance density was a play here too. You no longer had to get more capacity just to get the performance you needed. You get the performance regardless of the amount of capacity you happen to have. And this is a critical part of really being able to take advantage of flash at scale. And so we've been working on this for quite some time, integrating NVMe to various parts of our array, internally for our NVRAM, adding it for our internal flash modules, extending it to expansion shelves of NVMe fabrics via Rocky v2 to the back end. And then, of course, adding Rocky v2 NVMe fabrics to the front end so hosts can interact with this. Now, that's all wonderful and great, but if no one can leverage NVMe in that scale, then does it really matter? Well, the short answer is no, it doesn't. One of our biggest partners and one of the biggest on-premises probably environments there is these days is, of course, VMware. And so we were design partners with VMware and adding the support into vSphere 7, into ESXi 7.0. Support for NVMe fabrics. We support today Rocky v2, RDMA over Converged Ethernet. This is also supported with Fiber Channel from a VMware perspective, and that's something that's Pure is adding fairly soon, NVMe fabrics via Fiber Channel. And this was introduced in 7. So not only does this open up the performance density, but also opens up the performance within vSphere itself and reduces the impact on CPU cycles too, because ESX CPUs are no longer waiting for slow storage. It's no longer waiting for its slot in the queue. So reducing the used percentage of your CPUs while also improving overall performance and concurrency of accessing that storage. And there's more work to be done in this. VMware is working on finishing up the VM kernel layer to replace the vSCSI inside of the ESX layer. So from the VM down to the data store, there's still some SCSI there, but from the data store and the HBA to the array, NVMe Fabrics has been opened up. And we've already seen some significant performance benefits, especially at large I/O sizes and large scales, where it starts to really significantly outperform existing SCSI-based implementations. And so keep an eye on the upcoming vSphere releases as VMware continues to move NVMe across their entire storage stack. And one thing I should mention, I forgot to say this in the beginning, even though I was reminded right before I started, if you do have any questions, please do make sure you put it in the chat. Thank you. So NVMe Fabrics, that's an important part of moving forward in the on-premises VMware environments. And in particular, I'll talk a little bit more about this when we get into Kubernetes towards the end. But adding low latency, quick storage operations into modernized applications, containers, and even virtual machines, of course, too, is a critical part of moving forward. As customers look at these new greenfield environments, what can I do to future-proof this from a performance perspective moving forward? And so NVMe Fabrics is the answer there. But the core bits and bytes of storage is not the only part of this story. As I mentioned before, simplicity, automation, lifecycle management is a critical piece around new stack environments. This is one of the reasons that the interest around hyperconverged grew out, is that, hey, I want to be able to manage and lifecycle manage my infrastructure It's from a single place. I don't want to have to go here and here to figure out how to do this and update this and upgrade that here and upgrade this here. But on the other hand, I also want the best of breed. I want the best storage. I want to be able to scale it independently of my compute. I want to be able to use the best compute I prefer, the best storage I prefer, and then also the hypervisor I prefer. And I want to be able to use all the VMware tools. And so VMware's answer to this was something called VMware Cloud Foundation. VMware Cloud Foundation was born out of something called the VMware Validated Design, VVD, which was basically a Excel sheet that said, hey, these things are all supported, and we go kick off this deploy that infrastructure via the various VVD partners. Now, that deploys via something called Cloud Builder. And what happens there when you deploy essentially a VVD, it deploys a new offering called SDDC Manager. And with SDDC Manager, it deploys your management infrastructure of your average VMware environment. So a management vCenter, NSX configurations, the vRealize suite optionally, and a few other tools that come in the VMware ecosystem. And that initial deployment that is managed by and deployed via SDDC Manager is called the management domain, a small cluster that runs those management virtual machines. And once SDDC Manager is up and running, you can then deploy additional vCenters, aka workload domains. Every workload domain is a one-off vCenter with its own cluster with ESX hosts that you can deploy, remove, resize, add hosts, remove hosts, move around to give you flexibility of different domains, different tenants, however you choose to want to deploy those infrastructures. But also SDDC Manager manages the lifecycle of them, updating the hosts, the drivers, the NSX requirements, et cetera, et cetera, et cetera. And when you deploy a new workload domain, you also choose a storage option. This is part of the attraction around VCF, is that it's not just tied to some internal storage inside of those hosts. You can use external storage and have no internal storage if you so choose. Of course, both options are valid within VCF. And when you deploy a new workload domain, there are two essentially options around how you can configure your storage. So first off, there's something called principal storage. Principal storage is what is deployed when you choose to deploy a new workload domain. And this can be a variety of different things. Today, this is VMFS on Fiber Channel, NFS, vSAN, and virtual volumes. And virtual volumes is supported as principal on either Fiber Channel or iSCSI storage. And so what does this really mean to be principal? Well, it means when you go and click through SDDC Manager and you say, I want a new workload domain, you say, hey, I want VMFS on Fiber Channel. I want it to be from this array. And so what happens here is when that compute cluster gets deployed, it ensures that that data store is available and present and configured and ready for use upon initial login of that vCenter once created. And so the first time you log into that vCenter, you will log in, you'll see, hey, my vVol data store via iSCSI is presented and ready to go. My VMFS data store on Fiber Channel is ready to go. My NFS mount is there and ready to go. Does that mean that's the only storage that you can use moving forward with that workload cluster? No, that's just what is present at the beginning. This is how you get started. This is the automation and making sure it's set up and configured appropriately. There's also something called supplemental storage. Supplemental storage is, hey, I've deployed a workload domain, and I can now add any other supported storage into that workload domain. So, hey, my vVols is my principal storage rather for my workload domain, but then I also want to add VMFS. I want to add an NFS map. Maybe I do also have vSAN in that environment that I want to use. And so supplemental storage is really any one of those things I mentioned before. The only thing that is only currently supplemental storage is VMFS on iSCSI. Everything on the left is also an option as, of course, supplemental storage. Is VMFS on iSCSI on VMware's roadmap? It is certainly on their consideration. I don't know any commitments on when that's going to happen, but they are aware of moving that into it because this is really the life cycle of what VMware does with storage with VCF. Is first, it's certified and supported. Then it's tested and qualified specifically with VCF, which makes it a supplemental storage option. Then, all right, how do we integrate it? What do we need to do in SDDC Manager to make sure this is configured, and not only configured, but configured correctly and across the board? Once that is done and it's built into SDDC Manager, then it becomes principal storage. And so if we harken back to the beginning of this presentation, you say, well, where is NVMe over Fabrics here? That is in the qualification stage for supplemental. It's still fairly new. NVMe Fabrics came out 6 months ago, 5 months ago. What month is it? What year is it? Earlier this year. And so this is still in the qualification phase to become supplemental storage. So look for that in the future too. But I want to talk a little bit more about virtual volumes with VCF. This is the newest principal storage option from VMware. And if you're not familiar with vVols, vVols at a high level is VM granular storage, or rather virtual disk granular storage. When you create a new virtual disk, it creates an individual new volume on the array and presents it up to that VM. When you snapshot it, the array snapshot it. When you resize, the array resizes it. It's essentially an automated infrastructure and certified ecosystem for basically RDMs. But of course, it's a lot more than that. In VCF 4.1 Pure, we were design partners with VMware on this to add vVol support into SDDC Manager. And there's a couple pieces to this. One was making sure vVols is configured appropriately. And vVols needs the VAAI provider, which is the management API that vVols uses from VMware to talk to the underlying array. And then also the vVol data store, which isn't a file system or a LUN or something. It's a quota. It's a capacity quota. This is how much you're allowed to provision from this array. So getting that stored and registered in SDDC Manager and then appropriately deployed in that new workload domain is what came in VCF 4.1 about 2 months ago. The other piece of this is iSCSI. You'll note that VMFS on Fiber Channel was already a pre-existing principal storage option because the work for that is switch side. You need to zone your switches and so forth. iSCSI, though, the work to configure that is indeed host side. This is an ESX thing that needs to be done. And so what was done in 4.1 is that the host needs to be prepped with your iSCSI targets and things like that. And then VCF does the hard part. VCF does the part that people usually do wrong. That is configuring your virtual switch environment inside of the vCenter and vSphere layer to make sure that the iSCSI network is configured appropriately, creating the right VM kernel ports on the host, associating with the right physical NICs, making sure that they have the right connectivity and that port binding is done. That is the part that most folks do wrong or entirely miss, because the problem with iSCSI is it'll work without doing that. It just won't work in the optimal fashion. You won't get the performance or the resilience that you can usually get when configured with port binding. And so VCF offers that automation up when deploying vVols on iSCSI as principal storage. So if you want to know some more about what's going on with Pure and VCF, see our documentation, how to set it up, you can check the link under that QR code. And of course, Google is, like always, your friend. Now to finish up here, compute is a part of this too. I'm not going to spend a lot of time on this, but we do have a converged offering that gets everything ready for what VCF needs. VCF needs compute, it needs switches, physical layer, and it needs ESX installed on those servers first. It doesn't need ESX configured or tweaked or tuned. It just needs it installed and ready to go and online with an IP. And so one of the offerings we have that we partner with Cisco is UCS platform with something we call FlashStack. Single line of support button to order a flash stack with a full flash array or flash blade, along with the UCS and the switching platform. We also have a tool called Smart Config that can deploy that from day zero. So taking the powered on and cabled environment, initializing the UCS servers, initializing the switches, the MDS, the FIs, installing ESX on them as well, getting it ready exactly where VCF needs to be able to take that host and put it into a new workload domain. And so the FlashStack plus Smart Config plus VCF solution is a fairly well end-to-end solution that customers can choose from Pure. But of course, any compute that's supported with VMware is a supported offering within VCF. All right, so VMware Cloud Foundation. That's a pretty high topic coming from VMware, pretty popular topic. VMware's putting a lot of energy into improving that and extending it across their ecosystem of products. But of course, something that's coming up more and more these days is Kubernetes and containers. There's been a lot of interest on moving to containerized applications, and it's really getting to a fever pitch these days, right? Central IT is starting to look at, hey, I see the need for us to manage this. This is no longer some just developers doing some things on the infrastructure. This is something we need to really manage and manage at scale. And there's a variety of reasons that customers are starting to really seriously look into containers and Kubernetes. Not that they haven't been for many years, but it's starting to hit that majority now. And it's, well, hey, I buy some software from some off-the-shelf vendor. They're now offering it up as a container. I need the ability to manage that. Our developers are using containers. They're using Kubernetes in their environment, and it's becoming a large portion of essentially shadow IT, or at the very least, a level of IT that is no longer being managed by the central IT office. And so what does this mean for disaster recovery? How does this mean for backup and restore? These things need to be figured out. And of course, when we're looking at these small, medium, large organizations, what are they generally running on premises? What is the most common compute platform? The most common hypervisor? It's, of course, VMware. And so VMware has been putting a lot of effort into offering the ability to run Kubernetes on top of it. Around 30% of Kubernetes deployments are sitting on top of a virtual infrastructure. A third are on bare metal, and a third are in public cloud. And that virtualized side is growing. So VMware's done a couple things. There's the Tanzu platform, which is their branding for the product suite around essentially anything containers in Kubernetes. And there's also a tightly integrated offering around their Kubernetes kind of managed service, which is called vSphere with Kubernetes, or recently renamed VCF with Kubernetes, or VCF with Tanzu, and vSphere with Tanzu. One version requires VCF and has a tighter integration around NSX, and then the one with just vSphere is really focused more around leveraging just virtual distributed switches, really opening it up to more that aren't necessarily customers around NSX and or VCF itself. But the thing I'm going to spend a lot of this time talking about is not necessarily Tanzu itself and the different flavors underneath that, but is of course the storage side. What is VMware doing around storage? What are we doing around storage? How are we working together around storage in a containerized environment, sitting on top of VMware, and of course within the context of Kubernetes itself? And the most probably common option today would be leveraging VMware's CSI driver. Their ecosystem around that is called cloud native storage. And cloud native storage is a couple parts. There's a control plane, there's a CSI driver, but this is how storage is leveraged. Now, CSI, Container Storage Interface, this is a specification that was built out for consistency of storage management and provisioning in a managed container orchestration platform like Kubernetes. So regardless of what underlying storage platform you are using, the front end, the interface to it from the container manager or the end user or the developer, whoever that might be, has a same look and feel around what they're actually doing and how they're provisioning that storage. Now, VMware's cloud native storage driver, as I mentioned, a couple parts. There's the control plane sitting within the vSphere environment. This is what allows Kubernetes essentially to authenticate and create virtual disks and provision and so forth. And then there's the CSI driver. They're plug into the Kubernetes layer that actually allows it to talk to that control plane and make the right decisions and present the right options up to the end user via the CSI spec. And what cloud native storage does in general is it provisions from VMware data stores, presents virtual disks up to the Kubernetes worker nodes, and then allows that to be used as persistent volumes within the container pods. So whether this be vSAN, whether this be vVols, whether this be VMFS or NFS, the storage from that storage layer is provisioned up to Kubernetes. And one of the benefits here is that you can leverage your existing storage infrastructure to continue running your virtual machines, but also alongside it, use that same storage infrastructure, the same backend, the same ecosystem, the same performance and integration that you have, but also with your Kubernetes environment, with your applications that have been modernized into containers themselves. So let's dig a little bit further into how this works. Because I think an important part around this, and I think one of the attractive parts of running VMware on Kubernetes is that a lot of people know VMware and a lot more people do not know Kubernetes yet. And so where do you start? Generally, it's easier to start from a place that you're comfortable with, that you know. Let's change one thing at a time. And so inside of the CSI spec, inside of Kubernetes, there's something called a storage class. And a storage class is essentially, hey, here's a grouping of storage you can provision from. And if you choose this as your class of storage, you're going to get this capability, this performance, this feature, whatever. VMware maps this storage class back to something called a storage policy. Inside of VMware, you can create storage policy that says, hey, if you create a new virtual disk, if you choose this policy, we'll make sure that it matches these requirements dictated inside of this policy. And so their CSI driver maps that to a storage class that you can instantiate within Kubernetes itself. Say, hey, this storage policy name maps to this storage class. So if someone provisions from this class, they get storage that is compatible with this policy. And this allows the VMware administrator, or whoever owns that infrastructure, to be able to create swim lanes and levels of service for the folks above it, the users above that layer, even if they don't necessarily know the ins and outs of what this storage is. And that's a key part of this policy to storage class mapping. Now, there are two ways of creating storage policies for external storage, especially with focus with something like Pure, but really any external block platform that also supports vVols, I suppose. One, tag-based placement. You can tag your data stores with, hey, this is Sally's data store, and then create a policy saying, hey, any data store with the Sally tag is permissible with this particular policy, and then create that as a storage class. Also with vVols, it's a little bit more intelligent. When you register a vVol array with VMware, that array tells VMware, these are the things that I can do. And so when you provision storage for me, tell me the policy you want, and I'll make sure it's configured that way. And I'll make sure it stays that way. So if someone makes some change or reconfigures something manually on the back end, VMware knows that it's been misconfigured or something has changed. So the benefit around vVols is that it's intelligent and that it's correct. If something changes, it gets updated and you know it, and you get a compliance warning within VMware. Of course, it is stricter. The capabilities are defined by the storage platform. Tags are infinitely flexible, right? You can tag anything with anything. That's, as I said, infinitely flexible. Blue, green, yellow, tree, dog, cat, whatever you want to do. Of course, they have to be correct. If you tag this as the dev array, but it's actually a prod array, that's a problem. So tags are flexible, but you need to make sure you have good change control around them. And so there is certainly a place for both of these. vVols with accuracy or maybe some more specific requirements that you need to make sure are correct, but tags with a little bit more flexibility around tuning what's there. And so both of these are options, and they're not mutually exclusive. For vVols, you can use both. Of course, VMFS is focused on tags. And one of the cool things around the Tanzu platform, using a Kubernetes deployment that is from VMware, is that they have some really great integrations from the vSphere interface. And so as I create storage policies, I can check the ones I want and automatically instantiate them as storage classes within Kubernetes. And so the VMware admin doesn't even have to log into and run that kubectl command you saw earlier on the storage class one to be able to instantiate these and allow these policies within Kubernetes. And this is one of the really attractive pieces around the Tanzu platform, is that particular option. So I've mentioned the term vVols. I've mentioned it a couple of times. Why is this an important part of Kubernetes? Well, I mean, the intelligence, the integration is a really cool thing, but also the data mobility. Because one of the things that containers opens up, that Kubernetes also opens up to a certain extent, but it's really more fundamentally around the concept of the container, is that they're no longer tied to some OS, and they're no longer tied to how that OS is deployed and what it boots off of and how that OS is configured. It's abstracted from a layer above. So a container running on bare metal to a container running on VMware to a container running in the public cloud isn't really any different. And because of Kubernetes, the deployment and control around them is the same where no matter where it is. The underlying pieces, the bits and bytes that's abstracted by it are different, but the data itself and the infrastructure is the same. And vVols open up a unique opportunity around data mobility that something like VMFS cannot do. A VMFS data store, a virtual disk provision from that data store, is a file on a proprietary file system. It's a proprietary file on a proprietary file system. And so to use that data somewhere else, you have to convert it. You have to have a slow copy process or a backup process that converts it, puts it somewhere else, and turns it into something else. But a vVol is just a block volume. It's just a SCSI object that's presented up to a VM, an OS, and that OS puts a file system on it. And that vVol, it can be presented as a vVol to a VM as a vVol, or you can take that, copy it, or take the exact volume and present it up to a physical server. Hey, it's NTFS. Hey, it's XFS. Hey, it's ext4, whatever. VMware does not format that vVol or do anything weird with it. And so what this really makes happen is that vVols, of course, are first-class objects within the VMware environment, but they're also first-class objects on the array. Every virtual disk is its own volume. And even in the VMware environment, you can specifically mark them as first-class objects. This is an FCD. And what an FCD is, it's essentially a standard virtual disk that can be managed and configured independently of a virtual machine. You can create that virtual disk without even associating it with a virtual machine. You can snapshot it without any virtual machine association. This was introduced, the concept of first-class disks, sometimes called improved virtual disks, many years ago, without much of a use case. Who needs a virtual disk without a VM? VMs were the whole thing. The VM was the application. But now with containers, and the fact that that container might live for a short time or a very long time, or might move around or be redeployed, the storage, the persistent storage, isn't really associated with some arbitrary worker node VM. It's associated with that container, which may or may not be in use. And so when that container goes away, we want that persistent storage to, well, persist. And so first-class disks offer a perfect option for providing storage with that. And so that's exactly what VMware CSI Driver does. When provisioning a new what's called persistent volume, it provisions a virtual disk from a data store, but not as a standard virtual disk, adding it to a VM. It creates a first-class disk using the first-class disk API. So this is a managed and integrated object into the VMware API without a direct association to a VM. And then that gets claimed or used by a pod running in that containerized environment, and that Kubernetes environment. So a persistent volume, you could kind of argue, is like a virtual disk, a file on a VMFS or NFS, or a volume in a vVol. In the claim is like then adding that as a pointer to the VMX file of a virtual machine, edit settings, and add this existing disk. That's conceptually how these things map to the underlying layer. So when you provision a new persistent volume, you specify a storage class, VMware storage policy, and that gets presented up. So these things all come together to really allow the option around data mobility. Maybe I want to move this container. Maybe I want to move this persistent data set. Or maybe more accurately, or more commonly, I might want to have disaster recovery as a service, or dev test in a different environment or a different infrastructure, an infrastructure where I need maybe more flexibility up and down. I need my resources when I need it, and I don't want it when I don't want it. And so that's where things are going. Right? And I said, multi-cloud doesn't necessarily need, hey, I want to run this exact application on AWS, and then tomorrow in Azure, and then tomorrow on VMware. That's not particularly realistic. But the ability to move data through DR is something that is of interest. And generally, that's going to be focused on the hybrid cloud. Multi-cloud for your average customer is really going to be, hey, I have on-premises environment, I have an AWS environment, or GCP, or Azure, or whatever, and I want to have similar processes to deploy to those different clouds. I might want the ability to move some data around via DR, via dev test, but I want similar processes around my different clouds. Because in the end, there really isn't a multi-cloud. There's your cloud. And that might have AWS, that it might have Azure, that might have VMware, that might have whatever. And it could even have VMware in the public cloud. And so this is something that we saw at Pure. We saw this obviously growing. I think the industry has seen that. It's not unique to us seeing that trend. And so we realized, well, we need an offering beyond just our physical storage sitting in your on-premises data center, or even your physical storage sitting in a colo data center sitting next to an AWS availability zone. And so what we did is we've rebuilt the back end of our FlashArray block offering into a product that we call Cloud Block Store. This is not simply a port of our operating environment into an EC2 instance inside of AWS. Cloud Block Store is multiple EC2 instances. Every virtual drive is its own instance, and there's a dual controller model leveraging two EC2 instances as well, back-ended by IO1 objects, moving to IO2 for fast NVRAM caching, also a write-read mode sitting on EBS, but then the persistent long-term store of that data is on S3 with DynamoDB running some of the services in the back end. And so the front end of Cloud Block Store is the exact same interface, same APIs, same features as our on-premises FlashArray. When using it, you don't know if this is really a FlashArray or Cloud Block Store, other than maybe looking at the name and the hardware model and the UI. But it's the same look and feel, the same model and integration of provisioning. But the back end, of course, is fundamentally different. On premises, we built the flash array for flash. In AWS, we built the flash array, aka Cloud Block Store, for AWS. And we also offer it in Azure, but that is in beta now, and that will be GA soon. And so in the public cloud, you may not be running a VMware environment. You might be, and I'll talk about that in a bit. But if you're not, we also have our CSI driver that can provision storage from Cloud Block Store to Kubernetes environments sitting in the public cloud. Provision from Cloud Block Store persistent volume claims via PSO. PSO will figure out where it should go, how it should be connected, how it should be configured, and whether you're using something like EKS or even VMware Tanzu sitting in the public cloud, Tanzu on VMware Cloud and AWS, or Tanzu sitting on EC2 instances. It can be leveraging Cloud Block Store and PSO as the CSI driver. And so our ability to move the data here is also important, is because a Cloud Block Store is essentially a flash array. We can replicate from a flash array to CBS across availability zones. We either our asynchronous replication or even our active replication across close AZs. And then region to region would be more the asynchronous via direct connect or VPN or whatnot, allowing these different clouds and the storage between them to be connected. And that vVols story I mentioned before is a key part of this. Because a vVol is just a volume, it's the same thing whether you're on-premises VMware or you're in the public cloud. So let's say we had VMware Tanzu deployed on-premises, Tanzu Kubernetes Grid. And we had some pod running with a persistent volume claim and a persistent volume that's using a vVol. We can then replicate that vVol from the flash array to Cloud Block Store. And the tags showing the metadata for that are persisted on that replicated object that gets sent to CBS. And we can instantiate Tanzu or EKS or what have you inside of AWS, redeploy that from our container registry with a persistent volume claim that points to that replicated object and importing that into it via our CSI driver called Pure Service Orchestrator. And so the data mobility of vVols opens that up. We don't have to convert it or change that object. It's just addressed or provisioned in a different way. Cloud native storage on premises with VMware and Pure Service Orchestrator in the public cloud. Now, maybe I don't want my Cloud Block Store running all the time. I don't want to be replicating to it, because one of the benefits around the public cloud is that I turn things off when I don't need it, right? Because I don't want to pay for it when I don't need it. Benefits or downsides, depending on how you look at it. And so one of the things we also offer is something called Cloud Snap. Instead of replicating directly to Cloud Block Store, we can replicate to object storage. So whether it be Amazon S3 or Microsoft Azure Blob or even an NFS target sitting somewhere, we can replicate snapshots of those objects to that cheaper object storage. And then when you need it, you can pull it into Cloud Block Store to actively access that data. This is the more DR as a service type of route, or potentially dev test, depending on how frequently you're doing this. Also, long-term restore and retention. So same kind of concept as before, but instead of going directly to Cloud Block Store, it's indirect. So we Cloud Snap that persistent volume, that vVol to S3. Then when we're ready, we deploy CBS, and CBS in AWS, for instance, is deployed via CloudFormation. Deploy that up, kick it off, deploy Kubernetes, or take an existing one we already have and redeploy that container, leveraging that replicated volume that's been pulled from the Cloud Snap object storage. So a lot going on in the Kubernetes and VMware world through their Valero backup and recovery processes and the replication process we're built in. We are design partners with VMware on cloud native storage and virtual volumes with a major focus around backup, recovery, and replication integration into their CSI platform. But there are other options of leveraging Pure in other places. Whether you have a flash array, whether you have a Cloud Block Store, whether you have anything running anywhere. A couple months ago, we acquired a company called Portworx. Portworx is a SDS storage layer that focuses explicitly on Kubernetes. And so backup, recovery, storage, all the stuff that you really need to be able to do true mobility of not only the data, but the application and the metadata of Kubernetes, encryption, replication, restore, et cetera, is all built into the Portworx offering. It can certainly sit on top of Pure, but it can sit on top of any storage layer and run anywhere that you run Kubernetes. And so Portworx is a really important part of our portfolio that can also run within VMware, sitting on Tanzu or something else. So there's a lot of options. There's a lot of paths to follow down here. I think we're going to see more and more consolidation around the Kubernetes world in the coming year and coming time. But there's a lot of cool stuff to be done in 2021. All right, so I want to finish up here real quick because we're getting to the end of our time. I talked about three main things: NVMe Fabrics, VMware Cloud Foundation, and of course, Kubernetes. These are big things. This is going to be our focus area. It's going to be my focus area and my team's focus area for the foreseeable time. But it's not the only stuff we do, and it's certainly not the only stuff that matters when it comes to Pure and VMware. And there's a lot of other stuff here that I don't have time to get into. Orchestration around our PowerShell VMware module, Ansible, Python module, vRealize orchestrator, and that's something we're putting a lot of effort into because that's becoming more and more important these days. Automation in general, infrastructure as a service through VRA, our vSphere client plugin, virtual volumes is a key part of that, and even traditional VAAI and investment around CSI, not only from our perspective, Pure Service Orchestrator, but also VMware CSI driver, and of course, Portworx. Business continuity around offload to cloud, our active replication, which we call active cluster, asynchronous replication, support for VMware's VMSC, virtual metro storage cluster, aka stretch compute clusters, and of course, Site Recovery Manager. And we have a plugin with that for our VMFS-based storage, and we also have direct integration with Site Recovery Manager for virtual volumes and the replication built in with vVols on the FlashArray platform. We have a couple ongoing design partnerships and a couple new ones coming up fairly soon to announce around an ongoing design partnership around NVMe Fabrics, Site Recovery Manager and vVols support, principal storage in general with VMware Cloud Foundation, and of course, cloud native storage and Kubernetes with vVols. We've been working with VMware closely to integrate those two things and really take advantage of what vVols has to offer in a cloud native environment. All right. So if you want some more information, there's a lot of places to go to it. We have what we call our VMware platform guide on our support site, support.purestorage.com. This should be fully open, so you do not need Pure credentials to go and read our guides and our best practices and things like that. You should be able to check it out there. We also have a YouTube channel which focuses explicitly on Pure Storage and VMware stuff. And just to kind of see what's going on, what's new documents, new videos, new blogs, you can check out what's new with Pure Storage and VMware, also on the support site, and that QR code will get you directly there. All right, so I want to thank you for everyone's time here. I appreciate the opportunity to present, and I hope everyone has a wonderful day. Thanks a lot.